Today we will discuss exponential coordinates of rotations. That is rotating a vector about given axis omega cap up to theta. Initial vector p of 0 is known and we are rotating about omega cap at an angle theta, up to theta angle theta. We want to find final vector. So see, this is the omega cap axis of rotation around which we want to rotate this vector. So suppose this vector makes an angle phi with omega cap, then this point, this is the circular trajectory, and this point is at a distance of p cos phi, and the radius of circular trajectory is mod p sin phi, and we want to find this vector, and we are rotating this vector at an angle with angular velocity d theta by dt. It may be 1 or not. We will discuss general topic. See this one, see here. This one is, suppose this one is x, this one, simply, suppose this one is x, this one is y, and this one is z. This is omega cap, this one, and we want to rotate, this is omega cap and this is the initial vector p naught, this way. This angle is phi and we want to rotate about this wooden stick axis, say omega cap, up to theta. So this is the circular trajectory. The plane of circular trajectory, it is perpendicular to this omega cap vector, this one, in this plane. So this vector, then after up to angle theta we want to find this vector. Here, this is the figure. This is xy 3.119. The vector p naught, p0, is rotated by angle theta about the axis omega cap to p theta. Let p of t denote the path traced by the tip of the vector, this point. The velocity of p of t is denoted as p dot dp by dt, is then given by p dot, that is dp by dt. It is equal to omega cross r. Velocity v is given by omega cross r. P is the position vector. So dp by dt gives the velocity of the tip point. Or it is according to omega cross r. Omega is angular speed, but here omega cap is the direction, and d theta by dt gives magnitude of angular velocity. So this cross p, this is as a whole omega, this is position vector. So we can consider the radius of circular trajectory, mod p sin phi. So according to v is omega cross r, then after dp by dt is theta dot d theta by dt, omega cap skew symmetric into p. Equation number 2, cross product definition in matrix form. So variable separable 1 upon p dp equal to theta dot into skew symmetric omega cap dt. Variable separable. Now integrating both the sides. See here. Now integrating both the sides. Integral 1 upon p dp from p of 0 to p of theta equal to integral 0 to t theta dot skew symmetric omega cap dt. But we know that integration of 1 upon p is log p to the base e. So initial point p naught and final position is p theta. Omega cap theta dot is constant. So taking out the sign of integration, and integral 1 dt is t. So 0 to t. Upper limit, lower limit. So log of p of theta upon p of 0 to the base e. This is multiplier skew symmetric omega cap theta dot t minus 0, so t. But d theta by d theta dot is nothing but d theta by dt, angular velocity, into t. This is the angle. So theta dot into t is theta. We have replaced. Now this is logarithmic form. Log of p of theta by p of 0 to the base e equal to this. So considering exponential form, p of theta equal to p of 0 equal to e raised to skew symmetric omega cap into theta. So subjecting P of theta equal to e raised to skew symmetric omega cap theta into P of 0. This is the initial position vector. Equation number 3. So this term represent the rotation matrix for this. This is the final vector, and we are rotating a vector in the same frame around some axis, say omega cap. So this should be what is suppose I am asking question, what is this term? What does this term represent? So this term e raised to skew symmetric omega cap theta represent the rotation matrix for P of 0. Let's now expand the matrix exponential e raised to skew symmetric omega cap theta in series form. In equation 3, this one is the rotation matrix, rotation omega cap theta for a vector P of 0. Now what about V's omega cross R? It's a class 11 physics, but we will revise it. This one is X, this one is Y, Z is coming out of plane of board. Suppose particle P is rotating around this point, around on the circular trajectory, this way. At certain instant it is at here P of t, and after some interval delta t it is here at Q at time t plus delta t. So during this time interval it has covered delta theta angular distance. So angular velocity is delta theta by delta t. It's the average angular velocity, but we want to instant angular velocity at this point. We have to take derivative d theta by dt, and during this to this it has covered this much of displacement, arc length pq, this much of distance. So r delta theta by delta t, this is the average linear speed, so r omega. But if you want to take instantaneous linear speed, omega is replaced by average omega is replaced by omega, so v is omega r. But now we want to introduce vector. See the circular trajectory, particle is performing circular motion around this circle. At certain instant it is here, and the instant velocity is this direction. This is the position vector, or it is rotating about this way. So angular velocity is coming out of the plane of this. So omega is this, r is this. So omega cross r gives velocity. So direction order is important. So v is omega cross r. We have used this here. So here omega is coming out of the plane, this one v is omega cross r, we are using this. Okay. Now we know that e raised to at in scalar form 1 plus at raised to 1 upon 1 factorial plus at square upon 2 factorial plus at cube upon 3 factorial plus and so on infinite terms. Now the matrix exponential e raised to at, that is I identity matrix plus at plus at square by 2 factorial plus at cube by 3 factorial plus and so on infinite terms. So using this formula, applying here e raised to skew symmetric omega cap into theta equal to I plus skew symmetric omega cap theta plus skew symmetric omega cap square theta square by 2 factorial plus skew symmetric omega cap cube theta cube by 3 factorial and so on infinite terms. So I as it is omega cap theta, omega cap square theta square by 2 factorial. For omega cap cube is given minus omega cap. Here I have given proof. Let omega cap is omega 1, omega 2, omega 3. So omega skew symmetric omega cap is according to definition 0 minus omega 3 omega 2, omega 3 0 minus omega 1 minus omega 2 omega 1 0. So square of this omega cap square, so as it is I have written. Now multiplying this row, first column, first row, second column, first row, third column. So 0 into 0 minus omega 3 square minus omega 2 square. First row, second column, 0 into this 0, 0 into this 0, omega 1, omega 2. Similarly, omega 3, omega 1, omega 1, omega 2, minus omega 3 square, minus omega 1 square, omega 3, omega 2, omega 1, omega 3, omega 2, omega 3, minus omega 2 square, minus omega 1 square. Now we want cube. So further multiplying, same matrix, then after same omega cap. So omega cap cube is this one matrix into this one. So this row, first column. See here, first row, initially I have written this way. I have not multiplied, but omega 2 it's a unit vector. So omega 1 square plus omega 2 square plus omega 3 square is 1. So this term omega 2 square plus omega 3 square we can write 1 minus omega 1 square. This one. If this one is added, this one is added. And this one is 1 minus omega 2 square. This one is 1 minus omega 3 square. So this matrix is reduced to this into same matrix. Now we are multiplying. If first row, first column. So this into 0, 0 minus omega 1, omega 2 into omega 3. This one. And this one is minus minus plus omega 3, omega 1, omega 2. So it is at 0. Similarly, you can multiply yourself. We get this one. Minus already here, this one. We have taken minus common here from this. Minus sign. So all the terms are opposite. So here final answer is 0 minus omega 3 omega 2, omega 3 0 minus omega 1, minus omega 2 omega 1 0 with minus sign here. So omega cap cube, skew symmetric cube is minus omega cap, minus omega cap. Using this here, we have obtained the result skew symmetric omega cap cube is minus omega cap skew symmetric. So omega cap 4. So omega cap cube into omega cap, but omega cap cube is minus omega cap into omega cap. So minus omega cap square. Omega cap raised to 5. So we can write this way: omega cap cube into omega cap square. But omega cap cube is minus omega cap into omega cap square. So minus omega cap cube. But omega cap cube is minus omega. So minus minus plus. So skew symmetric omega cap. Similarly, omega cap 6. So we can write this way: omega cap raised to 5 into omega cap. This is simpler than this one. So omega cap raised to 5. We have obtained omega cap as it is. So this one is replaced by omega cap into omega cap. So omega cap square. So now omega cap raised to 7. So using this omega cap raised to 6 into omega cap. But omega cap raised to 6 is omega cap square and into omega cap. So omega cap cube is minus omega cap. And skew symmetric omega cap raised to 8 is omega cap raised to 7 into omega cap. But omega cap raised to 7 is minus omega cap. So replacing this minus omega cap into omega cap. So minus omega cap square. So all terms we can convert into omega cap or omega cap square with positive or negative sign. And remember this also: sin theta is theta minus theta cube by 3 factorial, theta raised to 5 by 5 factorial minus theta raised to 7 by factorial, plus and so on, infinite. Using this, we have written a function in the form of infinite series. Similarly, cos theta 1 minus theta square by 2 factorial, theta raised to 4 by 4 factorial minus theta raised to 6 by 6 factorial into plus theta raised to 8 by 8 factorial and so minus and so on. So 1 minus cos theta, this term, so terms becomes opposite: theta square by 2 factorial minus theta raised to 4 by 4 factorial plus theta raised to 6 by 6 factorial minus theta raised to 8 by 8 factorial plus and so on. This is very useful. Using this infinite series, we can find sin theta for any theta. After making software in a computer up to 50,000 terms, 60,000, we want whatever we want accuracy, we get this result at this much of accuracy. But here we will use this result also. Now see here, e raised to omega cap, this one square theta cube and so on, this one. So I as it is, this one is as it is, this one is as it is. But omega cap cube is minus omega cap. We have already studied into theta cube by 3 factorial. Then after omega cap cube, so omega cap raised to 4, theta raised to 4 upon 4 factorial. But omega cap raised to 4 is minus omega cap square into theta raised to 4 upon 4 factorial. Plus a further term omega cap raised to 5, theta raised to 5 upon 5 factorial. But omega cap raised to 5 is omega cap. and then after omega cap raised to 6 into theta raised to 6 by 6 factorial. But omega cap raised to 6 is we have obtained omega cap square reduced to omega cap square. Similarly for 7, omega cap raised to 7 into theta raised to 7 by 7 factorial. But omega cap raised to 7 we have obtained minus omega cap. So this one and so on this one. Now readjacent term I as it is, and rearrange the omega cap, omega cap, omega cap and omega cap square, separating the terms. So this one is omega cap, this one is omega cap, okay, this one is omega cap, this one is omega cap. So all such terms taking common omega cap, we have theta minus theta cube by 3 factorial, theta raised to 5 by 5 factorial and minus and so on, plus omega cap square, this one, this one, this one, this one and so on. So omega cap square into theta square by 2 factorial minus theta raised to 4 by 4 factorial plus theta raised to 6 by 6 factorial minus and so on. But we have studied already, this is nothing but sine theta. So I plus sine theta skew symmetric omega cap. Similarly, this one is nothing but 1 minus cos theta, 1 minus cos theta. So omega cap square. Remember this. This is the rotation matrix from Rodriguez rotation formula. So rotation matrix omega cap theta is I plus sine theta omega cap skew symmetric into plus 1 minus cos theta omega cap square equal to e raised to omega cap skew symmetric into theta. That is, this one is nothing but the rotation matrix I plus sine theta into omega cap plus 1 minus cos theta omega cap square. This one. Okay. Do you know d dx of log x to the base is 1 upon x? How? Let z equal to important limit. First we will study, because of to obtain this we require this. Let z equal to 1 plus x raised to 1 upon x. As x tends to 0, z tends to what? According to common sense, 1 plus x tends to 0, 1 plus x tends to 1 and 1 upon x tends to infinity. So it should be going towards 1, but the answer is not true. As x tends to 0, z tends to what? If x equal to 1, 1 plus 1 raised to 1 by 1, that is 2 raised to 1, that is 2. If we take x equal to 0.1, because of x tends to 0, so we can take take value of x smaller and smaller, and we are going towards 0. So we first we take 0.1. So 1 plus 0.1, 1.1 raised to 10, we get 2.59374 something. If we take x equal to 0.01, 1 plus x is 1.01. 1 by 0.01, that is 100. So 1.01 raised to 100, 2.7048138. So if x tends to 0, this number is not becomes infinite. It goes to limit x tends to 0, 1 plus x raised to 1 upon x equal to e, Euler number, which is 2.71828 something. It's not recurring, not ending. It's an irrational number. Now we will use this limit for the differentiation of log x to the base e. Now suppose y equal to f of x equal to log x to the base e. We want to find dy by dx. dy by dx is nothing but limit delta x tends to 0, f of x plus delta x minus f of x upon delta x. The numerator is delta y and the denominator is delta x. So it is the average rate of change of y with respect to x. But if you take limit delta x tends to 0, it is the exact rate of change of function. So limit delta x tends to 0, f of x plus delta x to log of x plus delta x to the base e minus log x to the base e, because of we have taken y equal to f of x equal to log x. So f of x plus delta x is log of x plus delta x to the base e minus log x to the base e upon delta x. Using the working rule for logarithm, log a minus log b, then log of a upon b. So limit delta x tends to 0, log of x plus delta x upon x to the base e upon delta x. So this one is multiplier 1 upon delta x by x is 1 and delta x by x as it is. So limit delta x tends to 0, 1 upon delta x log of 1 plus delta x by x to the base e. So limit delta x tends to 0, this multiplier goes to here in the power. It is also the one of the rule of logarithm. Log of 1 plus delta x by x 1 upon delta x raised to 1 upon delta x. Log of 1 plus delta x by x raised to 1 upon delta x. Logarithm of this term. Now we want to use this limit x tends to 0, 1 plus x raised to 1 upon x. X tends to 0 and 1 upon x is reciprocal. So here also x is a definite number and delta x tends to 0. So delta x by x tends to 0. So if here x by delta x, then we can use this result. So adjusting this term, limit delta x tends to 0, log of 1 plus delta x by x raised to x by delta x raised to 1 upon x. So x cut out as it is, same the term. But we want to use the important limit. So we have adjusted mathematically this way. Now 1 upon x is the power. So limit delta x tends to 0, 1 upon x here, log of 1 plus delta x by x raised to x by delta x. This goes to 0, so this goes to infinity. So if you consider this term as p, so limit p tends to 0, 1 upon x, as x is a definite number, variable number is delta x. So log of 1 plus p, if this is p then this is 1 upon p. And we have already studied limit p tends to 0, 1 plus p raised to 1 upon p is e. So 1 upon x as a multiplier constant bahar outside. So limit p tends to 0, log of 1 plus p raised to 1 upon p to the base e. But it is e, this one is e. So 1 upon x into log e to the base e, but log e to the base e is 1 because this one is e. So 1 upon x into 1 is 1 upon x. So d dx of log x to the base e is 1 upon x. So integration of 1 upon x with respect to x is log x, vice versa. Okay. Now we will obtain sin x in terms of infinite series and cos x in terms of infinite series. General infinite series form, Taylor series, f of x equal to sigma n equal to 0 to infinity, nth derivative of f of a upon n factorial into x minus a raised to n. But taking a equal to 0, one of the case of Taylor series, Maclaurin series, f of x equal to sigma n equal to 0 to infinity, nth derivative of f of 0 upon n factorial into x raised to n. We have derived this also in our previous video. You can go through our playlist, but now we will use directly. Taking f of x equal to sin x using this formula. So f dash x is cos x, f2 of x second derivative minus sin x, cos x minus sin x, f3 of x minus cos x, f4 of x minus plus sin x, f5 of x sin x cos x derivative sin x is cos x, and so on. So sin x equal to the first term, taking n equal to 0, that is no derivative. So sin 0 upon n is 0, so 0 factorial into x raised to 0. This is the first term. Plus f1 of 0, but f1 is cos x, so cos 0 upon 1 factorial into x raised to 1. Then after f2 of 0, so minus sin 0 upon 2 factorial into x square. f3 of 0 minus cos 0 upon 3 factorial into x cube. f4 of 0 sin 0 upon 4 factorial into x raised to 4. f5 of 0 cos 0 upon 5 factorial into x raised to 5, and so on infinite terms. But sin 0 is 0, so term this is 0. Cos 0 is 1, so x. Sin 0 is 0, so cut out 0. Minus cos 0 is 1, so minus x cube by 3. This is 0. Cos 0 is 1, so x is 5 by 5 factorial. And another term is minus x to 7 upon 7 factorial, plus and so on. So sin x is x minus x cube by 3 factorial plus x to 5 by 5 factorial minus x to 7 upon 7 factorial plus and so on infinite terms. The series is convergent. For given x say 60 degree, that is pi by 3. The sum of these infinite series goes to sin 60, which is root 3 by 2. So using this, we can obtain for any theta, for any angle x, value of sin x using this. If we take more terms, we can't take infinite terms, but a certain limit of terms, 60,000, 70,000. So according number of terms, we can get accuracy. Now taking f of x equal to cos x. So f1 of x, first derivative minus sin x, second derivative minus sin x, so minus cos x. Third derivative is plus sin x, minus into cos x, derivative cos x minus sin x, so plus sin x. Fourth derivative sin x plus cos x. So fifth derivative cos x, so minus sin x, and so on. So cos x equal to, using this, f of 0, that is no derivative. So cos 0 upon 0 factorial into x to 0. f1 of 0. So f1 is minus sin 0 upon 1 factorial into x to 1. f2 of 0, so minus cos 0 upon 2 factorial into x square. f3 of 0 sin 0 upon 3 factorial into x cube. f4 of 0 cos 0 upon 4 factorial into x raised to 4. f5 of 0 minus sin 0 upon 5 factorial into x raised to 5. x6 of 0, so minus cos 0 upon 6 factorial into x raised to 6, plus and so on. But cos 0 is 1. 0 factorial we have considered 1. X of 0 is always 1, if x not equal to 0. So 1, this term is 0, minus x square by 2 factorial, this term is 0, x raised to 4 by 4 factorial, this term is 0, minus x to 6 by 6 factorial, plus and so on. So this is infinite series. Cos x we have written in terms of infinite series. We have used in this in our theory. Okay.